Hello everyone. In this video we're going to be looking over more one-dimensional motion with constant acceleration. And here we have Bobby J again risking it all. So it's Friday night and Bobby J, he's inside the lab with his professor. And he bets his professor $20 that he has a light plane that can reach takeoff speed in 53 meters. Given that the plane accelerates uniformly at 3 meters per second squared and has a takeoff speed of 33 meters per second, does Bobby J lose his money? So we have to understand something. This is pretty high stakes because this is a university student and it's Friday night, and that $20 can make or break a weekend. So we're gonna see if Bobby J actually gets this thing right, or if he loses out to his physics professor, who's eerily silent throughout the bet. So without further ado, let's begin. So we have this airplane. We're going to assume that this airplane is starting from rest. So we're going to assume that the initial velocity is 0 meters per second. They didn't say otherwise. So generally, when things are not explicitly said otherwise, or they cannot be inferred, or it does not make common sense to assume them, then generally you make them 0. That's something that I learned along the process of doing problems. Sometimes you're wondering about all these other variables, how fast is the plane initially moving? Well, they didn't say, so let's just assume that the plane isn't moving at all, because you wouldn't be false for assuming that if it's not said or if it can't be inferred from what you're reading. So the plane is initially moving at 0 meters per second. And we also know that it moves with a constant acceleration of 3 meters per second squared. And we know that the final velocity that it must be at is 33 meters per second. So the real question here is, in what distance does this plane have to travel to reach this takeoff speed? Well, let's find out. So we have our acceleration in the x, which is 3 meters per second squared. We have our initial velocity, which is 0, and we have our final velocity, which is 33 meters per second. And it's looking a lot like we're going to end up using this equation again. Now, it's not a must that we use this equation all the time, but it just so happens that we have acceleration, we have initial, we have final, and we're looking for the distance. And in this equation, we have final velocity, initial velocity, we have acceleration in the x, and this is our one unknown. We have 4 variables here. We have 3 knowns, so we can use this to find our one unknown. So our final velocity is 33. This is 0 plus 2 times 3 acceleration in the x. So acceleration in the x, and I'm going to divide both sides by 2 times 3, which is 6. So I end up with 33 squared divided by 6, which is, oh my goodness, Bobby J, I am so sorry, which is 81.17. Oops, terribly sorry. Have to be very careful with your labeling sometimes. 88.17 meters, which is much greater, well, not that much greater, which is greater than 50 meters. So it looks like Bobby J he's down by $20. This problem it's pretty fundamental, and again, the most challenging part about a physics problem at this level is setting up the problem. Start off by drawing a diagram and really simplifying it as much as you can, because you're looking at an ideal situation. We're not considering the resistance due to air. And there are a lot of things that we neglect just for simplicity, because this idea, this model is good enough to fit a real world situation. So we know that the initial velocity we assume to be 0, and we know that the acceleration is 3 meters per second squared, and we know the final velocity is 33 meters per second. So we can use equation number 2 to find the change in displacement, which would be the distance that the plane has to travel to reach that takeoff speed and safely leave the ground. So not only is Bobby J down $20, but he's proven that he should not pilot planes. And in that regard, thank you again, and give yourselves a pat on the back, because physics is not for the faint of heart. It requires a lot of time, and it requires a lot of dedication. And if you're here right now watching this video, it already means that you're halfway there. So keep on fighting, and I'll see you guys later.